Hello everyone, welcome to my talk at Kubernetes Community Days, Bangalore 2022. The title of my talk is Managing WebAssembly Applications with Kubernetes. A very quick introduction about myself. I'm Shivai Lamba. I'm currently a contributor and one of the community members from Layer 5, which is the community for service meshes. It has a number of different projects currently incubated under the CNCF, including Meshery, which has been incubated for quite a few months now. And I've also been a Google Code mentor for CNCF, again for the Meshery project. And I've also been a former meshmate and maintainer for the Meshery project. So without wasting any further time, let's get started. So first thing, let's start off with what exactly is WebAssembly. Today, we know that WebAssembly is growing really popular. So let's just try to understand what exactly is WebAssembly, and then we'll move forward. So WebAssembly, it's essentially a binary instruction format. And you can just think of it as a really small, efficient, highly secure stack-based virtual machine that doesn't really care which particular CPU or OS it sort of works on. It's a format to sort of define instructions that an appropriate interpreter can execute. So essentially, it's basically designed to execute portable bytecode, which is sort of compiled from languages such as C, C++, Rust, Python, and sort of runs at near native speed because it directly interacts with the OS or with the system itself. And originally, it was designed to be work with web browsers. It is not meant to be sort of a replacement for JavaScript, but basically work with JavaScript to allow other programming languages to be actually able to run their execution on the browser for a lot of tasks that required much more compute power. So originally it started on the client side, but now it is also actually being able to run on server side and also in edge applications that are, of course, not related to the browser. And now we have at least some sort of support for multiple scripting languages and also, of course, general languages such as C, C++. Then let's discuss about WasmEdge. So WasmEdge is basically a CNCF sandbox project that is essentially a lightweight, really high performance and extensible WebAssembly runtime that has been specially designed for cloud native, edge, and decentralized applications. And it is one of the fastest runtimes that is available right now for WebAssembly because of using LLVM. And of course, previously it was also known as server-side virtual machine, SSVM. So that is WasmEdge. Now we'll talk about why exactly does the Kubernetes community need WasmEdge, right? So we know that Kubernetes managed microservices today are gaining a lot of popularity, and essentially that raises the demand for lightweight containers that are appropriate for such kind of workloads. Now, if we compare WebAssembly with Docker containers or Linux containers, WebAssembly provides a much more better security, isolation, and also cross-platform support as compared to Linux containers. When we talk specifically about edge-based devices, which have very limited amount of resources, and also we know that Linux containers, can actually be very cumbersome and also can be highly resource intensive when we are specifically talking about edge-based devices. That is where the Wasm based devices are actually much more better. So if you're using let's say Wasm as a container as compared to Linux, Wasm container will actually be just 1% of the size of a Linux container application, and also will be really helpful for running on edge devices since they run natively directly on the device itself. And of course that means that they have a very less start time. That makes WebAssembly really great for edge-based applications that will be part of the Kubernetes ecosystem. But of course there is certain pain points that are there. So with WebAssembly, they require its own set of language SDKs, compiler toolchains to basically to actually run it. That makes it a little more constrained developer environment as compared to Linux containers. So what's the solution is that we can actually run the Linux containers and the WebAssembly application side by side in the same system, and developers can actually leverage the use of container tools such as Docker, Kubernetes, Cryo-O to essentially deploy these WebAssembly applications alongside the other Linux containers as well. So let's try to understand how can we actually achieve this. So our goal is really to load and run the WebAssembly OCI images side by side with the Linux OCI images that essentially, for example, contain things such as Docker containers across the entire Kubernetes stack. And how will we sort of achieve this? So let's say that if we have Kubernetes at the top, of course, there are multiple ways in which we can run Kubernetes. We can have Kubernetes itself, or we can have smaller versions such as K3s, kind. All of course, these are all different type of runtimes that allow for deploying and running Kubernetes pods. Then of course comes with the high level container runtimes such as Cryo, containerd. So you can either use Cryo or you can use containerd. Then you of course have the lower level container runtimes, which are the OCI runtimes. So you can either use a C run, which is based on C, and you have other ones based on other languages as well. And finally, one side you have the Linux container images, and the other one would be the WebAssembly app images. So this is the container ecosystem that we're going to be looking at, and now we look at a step by step on how you can actually achieve this. So first, what we are going to be talking about using CRun, right? So basically the CRun project now actually supports WasmEdge as one of the container runtimes. As you mentioned, that WasmEdge is basically a runtime for WebAssembly. And since CRun is widely supported for the Kubernetes ecosystem, that essentially means that now WasmEdge applications can run anywhere, wherever there is support for Kubernetes. There are a few prerequisites that you'll need in order to actually accomplish this. So the first one is Cryo. You can look at this link that is there in the slides to basically set up and install Cryo. It's essentially a high-level container runtime that basically pulls images, for example, from Docker Hub, manages them on disk, and launches basically a lower-level runtime to run all the different container processes. Then we'll need WasmEdge itself, and also we'll need Kubernetes. Again, if you want to use a local installation of Kubernetes and run local pods, you can follow the particular link to install and actually run Kubernetes directly locally in your system. So the first thing that we'll do is that we'll start running Kubernetes. So you can follow the following commands in a terminal window so that it sets up Kubernetes inside of your local development environment. The next thing that we'll do is that we'll actually start our Kubernetes cluster. So you can follow all these specific commands to start the cluster. And essentially this will allow us to run the WebAssembly programs in Kubernetes as containers in the Kubernetes pods. And then for running the WebAssembly application in Kubernetes, we'll basically take a simple WebAssembly WASI program that is currently a part of a container image that we are fetching from Docker Hub. And we are going to be running it in the Kubernetes cluster. So you can follow this particular command to basically run this so that it fetches the container image from Docker Hub and then actually runs it on the Kubernetes cluster. Once it has successfully done that, you should be able to actually see the following output, where basically we are running the WASI example .wasm file, and we see the file content as well. And that way we're able to actually run our WebAssembly application inside of a Kubernetes pod, inside of a Kubernetes container. So what's next, right? So as we know that in Kubernetes application, one of the most popular architecture is for microservices, and how microservices sort of help to sort of move away from the monolith architecture and actually run these containerized services independently. And Wasm is actually very suitable for such kind of use cases, because WasmEdge can be used for distroless debugging and actually running these containers, or let's say as a service mesh as well. And when you're sort of combining Kubernetes with WasmEdge, it has a lot of wide range of applications, especially if you're running on edge-based devices. And here are a few resources that you can sort of look into to basically run Wasm on Kubernetes. So apart from the WasmEdge project, you also have Crustlet that allows to basically run WebAssembly in Kubernetes. That's also one of the other alternative that you can actually look at. And of course, there are some other projects that are currently there to basically help convert WebAssembly to OCI compliant that can actually be run directly in Kubernetes. So you can sort of have a look at all of these different resources. And of course, if you have liked my talk, you can connect with me on my Twitter at @howdevelop in case you have any questions from today's talk. And now I'll be more than happy to take up any questions. Thank you so much for attending this talk, and I hope to see you in person very soon in other Kubernetes community days events, including KCD Bangalore. Thank you very much.